Okay, now we're ready to take a look at area figures. We talked about perimeter in 10.3. 10.4, we're going to be looking at areas of various polygons and as well as circles. I guess a circle you could think of as a polygon with an infinite number of sides. But let's go ahead and get started here. So area and circumference. Now circumference is the equivalent of perimeter for a circle. So we'll have basically every shape in our pantheon of shapes. Okay, so here we go. The first thing we start off with is that everything really is based on the area of a rectangle. And this, in some sense, is a little bit easier to understand than any of them. When we have a rectangle, we've got the length and the width, and the area is going to be length times width. So let's say it's 4 long, so we could cut this in half. Watch over here. Cut that in half, cut this in half, we'll cut this in half. So it's 4 along the bottom, and let's say it's 3 along the top, or 3 along the width. So a length of 4. And these are supposed to be equal, making into little squares, and again it's not quite right, but then what we could do is these squares should be 1 by 1, right? This is 1, 2, 3, 4. This is 1, 2, 3. And we could just count the squares. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And indeed, 3 times 4 does equal 12. And what we have now is, say these were in inches, we would have square inches, or inches squared. Because we multiplied by inches twice. Okay, with the square, the same type of thing. Base times height, which is, since the sides are the same, it's side square. So if it was a 2 by 2 square, notice 2 times 2 gives us 4. So it gives us a very clear visual of what area is. It's really a simple concept. Let's just measure things with little squares, 1 by 1 squares. Okay, and they fit nicely, perfectly into squares or rectangles. Okay, so everything else, as you're going to see tonight, is based on this concept. So when we get you into some problem solving, and I'll do a problem solving video in a little bit later, but this isn't a rectangle, but what we can do is we can divide it into 2 rectangles and then add the areas. So at this point we could draw a line here and cut sort of a big rectangle along the top and the side, or we can draw one here. It's really up to us. I'll just do it here. And so I've got one rectangle that's 3, this is 6, and since this is 3, this is also 3. So what I really have is a 3 by 9. So the area of this part I calculate as 3 times 9, which that gives us 27. And again, it's going to be in feet, square feet. And then this part here, this is 13 and that's 3. So that's going to be 3 times 13. And notice the order I do the multiplication doesn't matter, because multiplication is commutative. So 3 times 13, that gives us a 39 square feet. And then we add those two together, this plus this, and our total area is going to be 50, 60, 66. feet squared. Okay. And the slide goes ahead and says, yeah, you got to cut it up. They cut it up the same way we did, or I did the same they did. So there's all the instructions right there, giving a total of, let's see, move out of the way, right? Watch what I'm doing. So if you add them together, we get the 66. 39 plus 27, 66 feet. They didn't give us the final answer. That's not, maybe they're, if we click one more time, I think it'll be gone. Oh, there it is. So they do give us the final answer. It's just what we came up with. So part of your problem solving is going to be, you'll be given shapes like this, figuring out how to cut it up into pieces. Take area here, here, add them together. Okay. There's some, I've seen, I'll look at the homework, but you can also take a piece out. So sometimes you find the two areas and subtract them, but you just have to look. And again, it's a sort of a problem solving, but you'll be able to get through those. Okay. Area of a parallelogram. So this is a slightly different one, and we're not going to be able to fit nice squares in there, but notice how they've got, there is a base, there's a height, and since it is a parallelogram, all sides are, these two opposite sides are the same, and the top and the bottom are the same. And so if we were to cut this off and then maybe put it over here, what would we get? If you do it enough times, you'll see you'll always end up with a rectangle. So a rectangle, we know, is just base times height, right? Just like what we did. And so a parallelogram basically can be manipulated, cut and paste into being a rectangle, base times height, or length times width, whatever you want to call them. And again, it's important that when we're doing this, that we're dealing with right angles. Okay, so when it wasn't a right angle, we couldn't just take, we had to do a proof sort of to show that it actually ends up being a rectangle. And this is one way. And watch, I've got a cool little video or a link here, and you can download the PowerPoint from Canvas, and then let's see if I have to change my pointer back. Let's get it to reload. And this kind of shows you, and it doesn't matter, you can do it from anywhere. Watch this. See, you start sliding it, it's going to measure the height, and notice the height's really going to be the same anywhere along in here. And I can move this, and then you can cut that piece. As it comes over, slide it over to the other side, and you have your rectangle. Okay, so you can pull this and play with it. This gives you filling or no filling. It's not really a lot of fun, but this part was kind of cool. You can see exactly a parallelogram can be cut and turned into a rectangle. Okay. So how do we find the area? Base times the height. Now just be careful. If they give us sort of this slanted side, that's not the height we're looking for. We're measure height perpendicularly. 90 degrees, straight up and down. Okay, and basically, solution 4 times 8, 4 times 6, 4 times 8, yeah. Multiply, that's 30, 32. And again, we end up with units that are centimeters squared, square units, because that's basically, we put a bunch of 32 squares would be in there, would fit inside this parallelogram. Okay. How about a triangle? Well, they give it to us as it's 1/2 the base times the height. We can see the base, the height. And what you look at this triangle is kind of, if we were to draw another one over here, it's half of a parallelogram. But don't take my word for it. Let's take a look at another animation. So here's one, and actually we're going to do 2 of these because there's different ways. And what's nice is you can play with this and you can get any size triangle you want. just leave it at that. And then you could slide this and make it, you know. So can you see, will it work with every triangle? And what this does is it cuts down, it swishes it around, and yes, we end up with a parallelogram, and it's going to show us that it is a parallelogram because the angles are the same. And so it's base, notice base times the height. And the height of the triangle is also the height of the parallelogram. Okay, come back here. We're going to get one more. This will do it a little different way to look at it. Okay. Let's come up here. And again, this one you can mess with the angles and make different shape triangles, different, I guess a triangle is a shape, but different sizes. And what it does is it gets the height. It's then going to cut the height in half. See, those are exactly half. And at the halfway point, it draws a line and cuts off the top, flips it over, and we get a parallelogram. And again, the rest is just showing that's a parallelogram. So it's a parallelogram is the base, and this height is half of the height of the triangle. Okay, so either way you want to look at it, a triangle is half of a parallelogram. So you use half the formula, or you could look at it this way, 1/2 the height times the base. Okay, both will work, but let's just put it in. So part of this is how are you going to remember this? Well, it goes back to the square, to the rectangle, base times height. Okay, and this is half. And so we're going to take 16 times 10 and then divide that in half. And again, yes, you can walk through it. You could have divided the height in half and had 5 times 16. You'll still get 80. Or you could multiply 16 times 10 and then divide it by 2. But there's going to be problems where you're going to do these triangles, areas, is just 1/2 the base times the height. Our last straight sort of polygon is a trapezoid. We're then going to get into circles, so that's what I was making here. So, and with the trapezoid, what it is it's got 2 parallel sides and 2 sides that are not parallel. And so what you can do is you can make 2 triangles out of it. And so you need the base times the height and the base times the height, but remember that's half of that for both of those. So the area ends up being half the height with the bases added together. And to kind of show you that, we've got one more animation. And this is, I like this one because you could make really kind of any kind of a trapezoid you might like to make. It goes ahead and draws a trapezoid, and notice it's taking base half of this side is where it knows it needs to make its cut. There you go, you got your 2 triangles. So notice you've got a base here and a height, base here, and watch what happens. Boom, you end up with a triangle, and the base of the triangle is now base 1 plus base 2, so it's 1/2 the height times base 1 plus base 2. So that's another way to kind of see where the formula comes up. And while you're here, if you want, there's a second way to look at it. You can play with any of these. There's all the same place. GeoGebra is a app that one of my colleagues used quite a bit, and it's an interesting place to go. Okay, so again, we've got the trapezoid that's given. We just sort of follow the formula. We add the 2 bases together. Here, 46 plus 32. We multiply times the height, 13, and we take half of that because that's how it works. Okay, and then again, and people took years probably to figure all this out and make sure it all works. But you know, look at thousands of years ago what they were able to build, the pyramids, mounds and everything. All cultures have been able to figure out ways of figuring out getting area, volume, and making it all work. Okay, we're into our last section here, talking about the circle now. So a circle is a set of points we're kind of familiar, that has a center point. So there's a center, and then the points around us are all equally distant. So we have two things we talk about. We talk about the radius, which is from the center to the outside, and we'll show you a picture here in a moment, and the diameter, which is all the way across the circle. Okay, so a radius is half a diameter. A diameter is twice the radius. So let's take a look at the first concept, which is the relationship between the diameter and the distance around a circle. And what's kind of cool, you can make different size circles here. When you want to play with that, we'll just do the big one because it's easier to read. But you'll see that it's all the same. So we're going to take this first diameter, and they're moving it out, that red diameter. There's one diameter, and then now the second diameter is coming, the green one. There's two full diameters, and then I guess that's orange, or is it yellow, yellowy orange? So there's three full diameters plus a little bit more. That little bit more ends up being 0.14. So 3.14. That's how we get the number pi, because that's exactly what the circumference is. So we take the diameter times 3.14, we'll always be able to get it. And the reason we do this is because we've got tools for measuring, our measuring instruments are all straight. Now we do have a measuring tape which you could wrap around, but you could test that out. But when you have straight measuring things, measuring rods and stuff, it's easier to measure the diameter, multiply it by 3.14, and you'll get your circumference. Okay. So that's all there is to it. Take pi, and they write it this way. This pi stands for, because it's not exactly 3.14, it's 3.1416, I think. There's a lot of decimals. It goes on forever. It's an interesting number if you want to use it. It does not repeat, but we can get by with 3.14. We'll do it for us. So 40 yards, which will approximately be 40 times 3.14 is 125.7 yards. So that would be the circumference, or distance around the circle. Yeah, and so now this is kind of getting us into the next area, is how do we get the area? There's a couple ways to do it. This is the one I found. So let's, what this is going to do is going to peel off kind of one layer of the circle and lay it down. So watch that. So notice how we get the first layer is the circumference of the circle. And then we're kind of like an onion. We're just peeling it off, and we're getting a shape that's going to look like a triangle, right? It is. So it kind of turned the circle into a triangle. The area of a triangle is 1/2 the base times the height. Well, what's the base? The base is the circumference. The height is the radius. So 1/2 2 pi r times r, we get pi r squared. Now, I need to back it up a little bit because we didn't talk about the circumference. We just talked about the circumference being the diameter times pi. But remember, the diameter is 2 radiuses, 2 radii, I guess is the proper way to say it. So 2r times pi is also the circumference. Okay, so again, we just have all of these and be able to use them. Now, what I would do is I'd make a little card, put all these formulas on that little card, and as you go through your homework, they're right there, and then you can use them. And what you'll do is, as you use them enough, you'll just come back and start remembering. Here we go, one more. Okay, so here we can use it to solve, like we got 2 pizzas to order. Which one's the better deal? So one pizza has a 16-inch diameter, $15. A medium has an 8-inch diameter that costs half. Okay, it looks like it's equally, half. This is like half the size, 8-inch diameter versus 16-inch diameter. But what we're going to see is that's not quite right, because the area of the larger pizza is the radius, which would be half of the 16, right? So they didn't quite go through. So 8 pi r squared. So we put in 8. Let's come back here. Okay, so what we had to do here is we have the diameter divided by 2 gives us the radius. So we took 16 divided by 2 and get that the radius of the large pizza is 8 inches. And we'll do the same thing, the smaller pizza, it's going to be 8 divided by 2. Which is 4 inches, the radius of the medium pizza. Okay, so with the large pizza, we're getting 201 square inches. That's what's edible. Of course, it depends on how much crust you get. You could do that calculation separately, but we'll assume, I don't know, don't assume anything, but the edible part is 201 inches, of course. And look at this. Whoa, the medium, because it's only a 4-inch radius, ends up only being 50 square inches. That's like that's a fourth. It's not half size. It's a fourth of a size. So if we were looking at comparable, it should be 750. It should be half that. It should be half of that. 350, 375 is what, as far as amount of pizza that you're getting. Amount of pizza. Of course, there's labor and all that kind of stuff, but what seemed like, hey, yeah, it's half the size, half the price, seems reasonable. But I would think that the pizza company is going to make more on a medium than they do on a large. Of course, again, the labor part of it, but the ingredients part, you're going to use more ingredients. That's 201 square inches versus 50 square inches. And again, they use take the dollars divided by the area. And so this is costing about 7 cents a square inch, and this is costing about 15 cents a square inch, about twice as much. So as far as pizza for the dollar, it's better. So that's how you're going to use these formulas to find area of circles, circumference of circles, and then areas of triangles, parallelograms, rectangles, squares, even trapezoids. So we can do it all. And that takes us to the end of (10.3), 10.4, and what we're going to do is our next section, 10.5, on volumes. So stay tuned for that. Work through these problems, get a good understanding, and you'll see that volume is the 3 dimensions that will just build off of what we've done here today. So take care, stay safe, and we'll be in touch.